Today we look at how to solve a second order differential equation using MATLAB and especially using dsolve command. Okay, so now here is the session number 11, and you're going to learn basically three commands. One is dsolve, inline, and feval. Right, these two are helping commands. Is a direct command that you need. Okay, so now basically the equation that we need to solve is like this. Okay, it is x double dot plus k by m times x will be equal to 0. This is basically a second order differential equation. This is equivalent in saying d squared x by dt squared plus k by m into x will be equal to 0, right? This is subjected to the conditions that the values of k and m is k is 20 Newton per meter and m is 0.5 kgs, and the initial conditions are given to you as x of 0 equals 1 and x dot of 0 equals 0. That means to say that the position at time t equals 0 is 1 and the velocity at time t equals 0 is 0. Okay, so now this is let's look at the how to write the code for this. We already have a code written here. First thing that you need to do here is d2, you need to identify the differential equation in terms of the strings. All right, let me increase the font size so that we'll be able to see better. Preferences, custom editor, wave 14 to 18 will be better, I guess. Okay, we'll go to editor. Okay, so now the given equation is this. Okay, d2 x double dot plus k by m x will be equal to 0. X double dot is d square y by d square x by dt squared. That I'm going to write it as d2y. Okay, or I'm treating in the code I'm treating x as y. Okay, so it's essentially saying like d squared y by d squared plus k by m times y equals 0. Okay, so this is the equation that we're going to solve. All I've replaced is x with y, and you know it really doesn't matter. And d2, this is d2 of y, and this is k by m replaced as it is, no changes. Y that will be equal to 0. So now the differential equation has been written in terms of a string. Now write the initial conditions. Y of 0 equals 1, and we also have dy of 0 will be equals to 0. Y of 0 equals to 1 and y dot of 0 will be equals to 0. Y dot of 0, that means that dy by dt will be equals to 0 at t equals 0. That means to say that dy of 0 will be equals to 0. This is initial condition number 1 and initial condition number 2. And go ahead and define your independent variable. The time variable t is the independent variable for us. So now we have to solve the differential equation. Dsolve is the command that you need to make use of. Dsolve, it has 4 input arguments, right? So now one is the differential equation which you have defined in terms of the string here, and initial condition 1, initial condition 1, initial condition 2, initial condition 2, iv independent variable, iv independent variable. Okay, now the whole dsolve of these 4 arguments is going to give you an output. Right, is going to give the solution of the differential equation. That SDE means solution of the differential equation, which represents the displacement y. Okay, let's go ahead and run this particular things. Copy or evaluate selection. Now it has been evaluated, yes, and we'll try to solve. I just wanted to see the solution, so I will run it without the semicolon and we'll see what happens. Okay, this is our solution that we get. And so we also are interested in seeing how the velocity varies, right? We got the amplitudes and the time rate of change of amplitudes or the velocities is here. Let's all I'm doing it is differentiating that the solution that I'm get with respect to the independent variable time, and I'm differentiating it once, right? So the solution, oops, very sorry, this is the solution. The differentiation of that is evaluate, right? So now this represents the amplitude, this represents a velocity solution. Okay, so now we need to define a function out of this. Okay, let's make a function out of this in order to evaluate the particular, in order to find out the values at certain times duration and the certain values of the k and m. We need to make it as a function. So inline, I am making an inline function here out of the solution that I have, right? So when I run this solution, when I run this command, you see that it has created an inline function in the name SDEY. SDEY is a solution to the differential equation, and the solution is representing the amplitude, and that has been made as a function, as an inline function, and this is the inline function. Okay, notice that it has automatically vectorized the entire equation, right? What do you mean by vectorized? See, for example, here t into minus k by m, here we do not have a dot here, right? So because when you have a vector, you are squaring an element wise element operation, you need a dot operation to be there, and inline function automatically takes care of that and puts a dot in between, behind the squaring operator of every variable that you write there. That is one thing. And let us also try to make a inline function okay, for the solution of the y dot, that is the y dot that we have obtained here as a function. And when I evaluate this, you can see that this is the function that it has created for the y dot. And now let us define our constants. Now k is 20 Newton per meter and m is 0.5 kgs, and time I want to go ahead and simulate it up to 10 seconds. Okay, lin space 0, 10, it's going to create a matrix of row matrix of 100 values between 0 and 10 with 0 and 10 included. So now we have created the time variable. All we need to do is evaluate the value of the amplitudes. Okay, amplitudes are stored in SD in a solution, and the solution has been created as an inline function here, and we are evaluating that particular inline function which is stored in this variable, right? So in effect, we are actually evaluating this solution to the differential equation at different values of our variables. All right, so now we have y is equals to f eval, that means function evaluate. We have just created an inline function here, we are evaluating this inline function here, right? Function eval, the moment I write this function is being evaluated. That means this value of the y is being calculated, right? Now what the value, at what values of the variables k, m and time, right? We have defined k, m and time here, and y dot also will be calculated like this. And now we get the solution. If we go ahead and do this evaluate selection, oh yes, we got the solution, and we need to plot it, right? So plot k evaluate. Okay, we get the graph of time along the x-axis and displacement along the y-axis. And hold on, and we make another plot, and we get the plot of the velocities along the y-axis and time along the x-axis. Velocity is being shown in the red line, and displacements are being shown in the black line, right? And we also go ahead and put a legend and to represent exactly what is what. And this is how you solve simple differential equation like this using dsolve command. And you can also solve it using ODE 2.3 and ODE 4.5 commands that will be coming up in the further videos.